Hi there. Welcome to this video where we're going to talk about the different situations for the side-side angle situation, which we call the ambiguous case. So with the side-side angle case, first of all, you have two sides and an angle. So when you identify the information that you're given, you'll look to see how many angles you have, how many sides you have, two sides and an angle. You could either have side angle side or side angle. Now, how do you tell those apart? With the side angle side, you're not going to have a pair of angle and opposite side. So with the side angle side, you might have side A, angle gamma, and side B, but you don't have that gamma C pair in there, you don't have the alpha A pair in there, and you don't have the beta B pair in. When I have side angle side, that's when we use the law of cosines. So side angle will be where you have an angle and two sides, but you're going to have a pair in there that is an angle and its opposite side. So there is either going to be an alpha and A, or a beta and B, or a gamma and C. So that's how you tell. Now, if you have that your given angle is acute. So remember, an acute angle is an angle that is between 0 and 90 degrees. There's a couple situations that could occur. First is that we have the side opposite the given angle is shorter than the adjacent side. So off to the right here is a demonstration of what might happen in the different cases. So in this situation, we have angle A, which in what we did in the tutorial was angle alpha. We have side B, and remember B is not opposite angle alpha, but we also have side A, and side A is opposite angle alpha. So I'm just going to start that so it looks kind of shows it off to the side. With the side angle case, what you want to do is draw a horizontal, measure the given angle off that horizontal. So here I'm showing it at 68 degree measurement. Now since that's angle A here, alpha for us, then side A has to be opposite that. So I'm not going to put it on the side that makes angle A. But whatever side I have other than side A, whether it's side B or side C, that will go on the adjacent side. So in this case, I have side B having the value of 5.5. Now notice 68 degrees here. It's an acute angle. And my side opposite, 3.3, is a smaller length side than my side adjacent, the 5.5. And if that side is too short, then I won't get a triangle at all. It'll just dangle. So under this, the side opposite the given angle is shorter than the adjacent side. If it's too short, you don't have any triangles, so 0 triangles. And if you were to set up the law of sines with 3.3 is to the sine of 68 degrees as 5.5 is to the sine of beta and try to solve it, you're going to get an error on your calculator. So that's how the calculator is going to show you that it is too short and you won't get a triangle. Now, what if it's just long enough to reach? And this is a little bit harder for me to do on this where it just hits. So let's see if we can get it where it just kind of, see right about there. Okay, pretty soon I'm going to just stop messing with it. Really close to there. This is showing 2 triangles because I can't get, you saw I was struggling with that, but if it were just a hit, then you get 1 triangle. And it'll actually be a 90 degree where the vertical meets the horizontal, so you'll actually get a right triangle there. And then if it's shorter than the adjacent side, but still longer than just touching, so if I make this maybe 5.4, notice that I get two triangles. So let me swing this. The first one you would get would be that one, the outside edge of it. And when you set up the law of sines for that, you're going to get an angle for, in this case, RB, that will actually be an acute angle. So it'll be somewhere between 0 and 90 degrees. And you've already seen that you had an acute angle given. Your side opposite your adjacent side was shorter, and you actually got an acute angle when you set up that first law of sines. That's when you have all that situation, that's when you have two triangles. So the first one I would get from solving this with the law of sines and then go through the whole triangle. And then we would swing that side over and see this very tiny little sliver of a triangle. That's the second one that you would get. So this is long enough to hit, past hitting. That's two triangles. All right, so now let's see if the opposite side is longer than the adjacent side. So I'm going to swing it back over here, and this time I'm going to make that opposite side a number that's bigger than 5.5, so longer than that adjacent side. Okay, so do you see that triangle? Now remember, angle A is opening to the right. So if I try to do that same process and let that swing over, it does not make another triangle that still includes that angle A that's facing to the right. So in that case, I'm guaranteed to just get one triangle. And I'll just get it from setting up my law of sines. I will get an acute angle for that, but I know my side opposite is a bigger number than my side adjacent, so I'm only going to get that one triangle. Okay, now we're going to the second part of this where the angle is obtuse. So now I'm going to take this angle A and I'm going to make it be an angle that's between 90 degrees and 180 degrees. So if I make that get bigger, about 112 there, and if I take this first case where the opposite side of opposite the given angle is shorter than the adjacent side when I have an obtuse triangle, so I'm going to make that side A be shorter than the 5.5. Notice it just dangles. I don't have enough length in that side to hit on that horizontal in the same opening of that angle 112 degrees opening to the right. So you'll get no triangles. And then last case scenario is if I have an obtuse angle and the side opposite the given angle is longer than the adjacent side. So if I'm going to let this swing that way, I'll stop it, and then I'll make that, let's get it one more swing to kind of stop over there. Okay, good. And now we're going to make this A be longer than the 5.5. And notice I do get a triangle, and I do just get one triangle. So if you have the given angle as acute, and the side opposite the given angle is shorter than the adjacent side, that's the one where you have to really put on your thinking cap and look through the different cases you might have, because it will either give you 0 triangles, 1 triangle, or 2 triangles. It will show in your work though. It will be 0 triangles if you get an error when you're applying the law of sines. It will give you 90 degrees back for that side opposite the one that originally was adjacent to the given angle, if it gives you 90 degrees. And if it gives you an acute angle for that, you know you've got the two cases. If you have an acute angle and the side opposite the given angle is longer than the adjacent side, just one triangle. Find it, you're good. If your given angle is obtuse, meaning bigger than 90 degrees, less than 180 degrees, and your side opposite is a smaller number than the adjacent side, no triangle. And then if you're given an opposite or given angle is obtuse and the opposite the given angle is longer than the adjacent side, that's when you have one triangle. Well, hopefully this demonstration has been helpful to sort out those cases. We've got another video that goes through a situation where you do get the two triangles and how to find the information from both of them. But thank you for joining me.